told you.
And we're back. Well, friends, country people, other friends, lend me your ears. We're almost at the tail end of another exciting calendar year. What does this mean for you, industrious, hard-working person who came down from the temple? Or you, lazy slob who can't be bothered to come down to the temple? And Kobe, who fits neither of those. I don't even know if Kobe watches anymore. Yeah.
He exists again.
He does exist, yeah. So Kobe was at my wedding last Saturday, and I saw him for, oh yeah, hey, I did a thing. Yeah, so I think I saw Kobe for the first time in like 2 years, which I also think coincidentally is the first time he's left his house. And I bet you he's probably watching tonight out of like a sick nostalgia for us, because he knows what he's missing, but he's back in his house again, and like somebody has him chained to the radiator. Yeah, hey Chris, what's that movie where like the guy's in bed, it's like winter outside, and Misery, yeah.
I was like...
Yeah.
Where she beats him.
Yeah, she beats him in the leg with a bat. That's what Kobe's going through right now, Misery.
That is the end result of factor.
So anyway, the Stash is saying some things. Little known fact, the Stash's mom is more technically competent than the Stash is.
Yeah, she's
No, I'm not exaggerating. Like, his mom has more street cred than he does right now. She works for VMware. Stash, yeah. So,
That's impressive.
She works for Y12. She's associated with VMware. She's had an IT career of about, no joke, 20 years, if not more.
I don't know if any, yeah. So an IT career of like 20 years or more.
That makes me feel
The
old.
Stash, like, I see him outside whenever it's trash day, riding the truck, and it's, yeah. So, last week, as a kind of recap for how we started off December, in the middle of December, we did happy, fun USB time with Charles Wong. Many laughs were had. Hopefully, Charles Wong is amenable to doing that again next year, in next quarter or something. Really successful pilot. We're grateful for how that went down. Dobby showed up out of nowhere and decided that in true Florida man fashion, he'd killed a gator on the way here, and he wanted to cook it up and share it with us. Miss Frizzle got her handle. Hello, Miss Frizzle. If you don't know what the Magic School Bus is, yeah. So what do we have this week? This week, we've got Disc0rdantmel0dy, the man bun himself, giving a talk on Active Directory and how to commit arson up in Montana or something. The talk's called Forest Fire, so that's what I'm going to assume it's about. So the reverse Smokey the Bear talk. Next week, we are starting the Christmas and other holiday season. There will not be a talk next week.
Yeah, I'm next week.
Oh, yeah, wait, you're next week. Okay. Okay, yeah, so Christmas is in 2 weeks. Next week is the season finale of Season 4 of The Temple. And every season finale, we have to end it with our own favorite semi-convicted felon, Chris Machowski, Macho Christ. And he is going to talk about something that he hasn't talked about in many, 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 many moons. Which, Monopoly money. How to print Monopoly money. That is, now correct me if I'm wrong, we're not streaming that, are we, Chris? I think we shouldn't.
If we don't stream it,
Yeah.
we can do some activities.
Okay, so I am making an executive decision. We will not be streaming. There will be arts and crafts next week. Come on down, even if you haven't been down here in like 2 years.
Let me rephrase. We can do what we've done before. And
Yeah.
where maybe we stream the first hour, and then for people that are here in the temple, we can do activities.
Well, we'll see. Okay. So, as it stands right now, the stream is a maybe, and we'll leave it at that. We'll do like...
We'll stream it, but if you want to do arts
Okay,
and crafts,
yeah.
you have to come down.
So we'll stream it, but if you want to be a part of grown-up arts and crafts, and know that's not making a prison fee, come on down. So, yeah, next week there's that. The week after, the week after we're not doing anything. Yeah, it's Christmas.
No, the 28th is the Christmas party.
Christmas.
Saturday.
Yeah.
probably.
Yeah, you have a Christmas party on the calendar,
Oh, that's right. Yeah.
and then that Saturday.
And then that's
Yeah.
so
Okay. Yeah. Please. I'm finally coming back to the real world here. So we are doing the temple Christmas party, where we take you axe throwing and dinner and all that fun stuff. On December 25th, for those of you who care, our Lord and Savior was born. For those of you who don't care, enjoy your capitalism.
Your badger was born the next day?
So we call it Mega Christmas.
Anyway, yeah, it's Mega Christmas because Danny was born the next day. So, in true Jewish fashion. So our beloved binary badger, the Chinese food of the guild, is born afterwards.
Oh, that feels low.
Yeah. Well, no, because it's like if you don't celebrate Christmas, you go get Chinese food.
That's Chinese food.
Yeah. Yeah. So the 28th is the Christmas party, and then that Saturday is the annual Neon Temple shoot. I will be your chief range safety officer, and normally, Coach East is all jokey and hilarious and fun to be around and charming, but not around guns. I'm super serious around guns. Our junior range safety officer, and he will have to wear a beret that says junior, is going to be Dino Dave. Yes, we're putting him in a beret. It could be, yeah, you earned one of those, but we'll put him in a beret. Yeah, so if you have guns, bring your guns. The theme of Range Day is LARPing, so dress up like the Stash, put on like a nice suit and tie, and show up with anime waifus on your guns. Yeah.
For a prone support, obviously.
Yeah, or
Shooting them like Hunter S. Thompson.
no, or if you're binary badger, show up dressed like you're a member of the Irish Republican Army. Or no, don't culturally appropriate my people. Yeah. So the theme of the day is LARPing. Show up however you want to show up. If you have guns, bring them. If you don't have guns, call it out. Call it out in the general chat. Call it out in event discussion, and see if somebody will loan you some guns. I've got a couple guns. I'll let you shoot. Yeah, ammo's expensive, but having freeloading friends is free. So, and after that, the shoot on the 30th. The final seat, this instance of the Neon Temple has come to a close, and we are on to next year, where we will be kicking it off from our new location right next to the airport, including having our own dumpster, which is exciting. I for one, am excited about a nice fresh dumpster. Yeah, I like a new dumpster. So with that, we are coming quickly upon a conclusion of the evening, and we will then go to our beloved discordant man bun melody with Forest Fire. Go.
Turn cold and the stars look down, and you'd hug yourself on the cold, cold ground. You wake the morning in a stranger's coat, but no one would you see. You ask yourself, who'd watch for me? My only friend, who could it be? It's hard to say it, I hate to say it, but it's probably me. Probably me. Probably. I hate to say it.
I can get, there we go. All right, well, welcome to the second part of my three-part series here. This is part 2 of the Forest Fire series. This is a kind of 101 in how to use, how to operate and use Bloodhound. So if you missed my first talk, I guess you're SOL because we didn't record that one or save that one because I was showing sensitive data. So we will be doing another talk sometime early part of next year that is in advanced AD Tradecraft. But tonight is going to be all about Bloodhound, our favorite AD tool. So I mentioned this before, but I'm a consultant. You can tell because I have agenda slides. So we're going to we're going to do some introductions. Then we're going to talk about kind of what Bloodhound is and how to set it up. Some tips and tricks to data collection with SharpHound. We'll go through a basic kind of how to do navigation of the UI and perform some basic analysis. We'll talk about the analytics, and then we're going to wrap up talking about Cypher, which is the query language for Neo4j, which Bloodhound runs on top of. Then we'll wrap up with some Q&A, as always. So for those of you who don't know me, I'm Disc0rdantmel0dy. Hi, Chris. I'm a bit of a dev nerd. I really like doing malware development. I run the offensive operations team over at Fulcrum Technology Solutions. And yeah, I'm really big into DLL, like implant execution. So I like to stick my DLL in strange programs. So let's just start with like kind of what is Bloodhound. The meme is courtesy of our favorite animal here. But yeah, at its core, Bloodhound is an Active Directory audit tool. It utilizes graph theory and allows us to visualize attack paths through Active Directory misconfigurations. So using graph theory and Cypher language, query language, we can quickly analyze complex relationships between Active Directory objects and have it presented to us in a way that our brains process most efficiently, and that's visually. There's kind of 3 parts to Bloodhound. You have an application that you run, a client. You also have a backend database server. That's your Neo4j server. And then you have a data collector, and that's SharpHound. The thing I really like about how Bloodhound is designed is the only part that interacts with your victim network is the data collector, the small C# tool. And we can execute that because it's written in .NET. We can execute it in memory using your favorite like C2 programs in memory execution, like Cobalt Strike's execute assembly, or God, I can't remember. Is it still called execute assembly in Sliver? I think so. But either way, like you can execute it in memory. It makes it very good, very easy to go underneath the radar with this. So I'm going to go through this. I'm going to fly through these slides real quickly. I really put these primarily in for a reference because the Bloodhound install documentation is kind of shit. To get Bloodhound up and running, the core thing, it's all about the prereqs. Make sure you have the Oracle JDK 11 installed. I have links for all of these in the slides, which I posted in the event details section. You need to install Neo4j Community, and then once you have all those 2 things installed, Bloodhound itself is just an extract and run. I'm going to kind of just glaze through here. You can quickly check your Java version by running Java -- version. If you don't have at least results of 11 or greater, you're going to need to install OpenJDK 11. The only caveat when you install it, like all of these, I just picked Windows because it's the easiest one to explain. But you just need to make sure that where's my laser pointer? Just need to make sure that Java home is variable is set when you install it, or you need to go and set it afterwards. Otherwise, Bloodhound won't work. You will need to install Neo4j. You can install that locally or remotely. I usually recommend just doing it locally for like one-off like exploration type stuff. If you're if you're a defender and you're looking at doing this for your actual statistics and things like that, I would recommend doing a dedicated Neo4j server. The key things to remember here is you need to install the latest version of Neo4j 4. Do not install 5x. There are known performance issues with 5x where your searches will just take forever if they ever come back at all. I put links to it. The big thing is just when you go to that link, you need to scroll down to the graph database self-managed section, which I have an image of here. And just a bit of a caveat, select your OS on the bottom first, because every time you change the OS, it'll default back to 5. That way you make sure you get the right version. Installation is pretty simple. Just extract the zip, navigate to the bin folder in your command line, and run the commands down here at the bottom to install the service and start it. It's as simple as that. The Linux install is almost the exact same. It's just different. There's an SH file instead of the BAT file.
Yeah, quick question.
Yeah.
It's been very much that touch Neo4j. Do they still require some sort of identity or login or thing with their website or to?
Yes. It sucks, but yeah. Although you can, it doesn't do any type of verification. You can sign up with a fake email. I've done that. As long as you just have to click a verify your email link.
I just briefly remember Neo4j.
Yeah,
it's representation of database. I'm like, this is awesome.
It's one of the reasons I didn't send you to the Java site for the OpenJDK is because they also require you to do identity, and they actually do like identity validate. You have to give them a credit card to prove who you are. So that's why I use the OpenJDK one in the links, because you can just download that straight from Microsoft with no validation. So after you install Neo4j, this part is really important. Don't forget to do this. You need to open a web browser, and you need to go to localhost or 127 home, port 7474 in a web browser, and log into the Neo4j console. The reason is Bloodhound doesn't have any way to reset the password from the client. So when the first time you log in, it'll force you to do a password change. And if you don't put anything, it'll generate a random password. So when you do that, resetting the password for Neo4j involves blowing away the database. So anything you've done since that, you'll have to go blow away that database. So yeah, just remember to go do this. It takes 2 seconds. I put the default credentials in the slide. It's just Neo4j twice. You'll have to reset it. You can, as long as you actually log in here, you will not be able to miss this step. And then the last thing is the binaries. Like I said, easy, extract and run. You'll use the credentials to log into Bloodhound, the same ones you set for Neo4j. And then the last thing is I have a link here from the Bloodhound Read the Docs that shows the installation paths for all of the OSs that are quote unquote supported. I will, like I said, the documentation there is parts of it are good, but parts of it are like the actual operations section is really good, but the install section is kind of hot trash. No offense to Waldo or Captain Jesus if they're watching this. So now that we got that out of the way, let's go ahead and dig right in. So let's talk a little bit about data collection. This is kind of, again, I've said earlier that SharpHound, the data collector, is the only part of the Bloodhound stack that interacts with your victim network. We want to make sure that we're using good OPSEC for this. So do not use your the precompiled binaries from the GitHub. That is bad. That is that every inch of that binary is signatured. Make sure you download the source code, compile it yourself. Even better, go in, find 5 or 6 random variable names in there, change them. Just do some. You don't have to do a lot of obfuscation because we're going to execute it in memory for the most part. But you do want to do some basic changes so you don't end up with similar hashes or other things that would just make it really easy. But at a core, all this does is just collects a bunch of data from AD. The cool thing about how Active Directory works is everybody who has at least domain user rights, so any user on the network that's validated has full access to everything in Active Directory. They just only have read access. But for what we're doing, that's perfect. We can basically download their entire Active Directory, which we do most of. So there's some various collection methods you can use with Bloodhound. And I'm going to only talk about a few. I'm going to talk about 2 that are really useful, and one that if you write, I will personally send coaches to your house to kick you in the nuts if you use it.
You don't owe me.
Yeah, but you'd enjoy it. I mean, well, I mean, you don't like kicking skids in the balls?
I mean, not if it puts me in jail.
Oh, that's fair. We'll get you a mask. We'll put you in RJ's Guy Fawkes mask. No one will know.
RJ did not invent the Guy Fawkes mask. My people did.
Anyhow, so we'll start with the one that I was warning that involves ball kicking if you use it, the default collection method. All good red teamers know you never run tools with their default settings. If you do, you get caught. It is a terrible idea because there's these wonderful little things called behavioral rules, and they will catch you all the time. Bloodhound's no exception. When you run the default collection method, you collect a limited amount of data, and it reaches out and talks to every computer in the entire domain. I really hope that I don't need to go too deep into explaining why this is a bad thing. But we will say that I will say that almost every Bloodhound detection I have come across has been based on the idea of looking for one-to-many relationships with SMB connections, looking for one host that's making a fuck ton of SMB connections all very quickly. Oh, excuse me, pardon my French. I'm trying not to do that when I'm on stream. I have a mouth like a sailor sometimes, so.
I'm sure we got a lot of kids.
Good. Anyhow, so the next collection method I want to talk about is the all method. If you were thinking that it's okay for you to run the default method because you're not worried about stealth, you're a defender, any number of reasons, you just suck at life. But if you think it's okay to run default, that's fine. Don't run default, run all. Because what all does is all does everything that Bloodhound can collect. The only collection it doesn't run is the GPO local group collection, and the reason it doesn't run that is because Bloodhound has 2 ways to collect local group information. One is to check AD for local groups in GPOs. The other one is to actually ask the host, what are all the users in your local groups? The latter is far more accurate. That's why it doesn't run this. So it runs a different version to grab an accurate version of the same data. This is the collection you run if you don't care about stealth. This is, and we'll talk a little bit about how to do something similar to this here on the next slides. And before any people who have used Bloodhound in the past decide to be a smartass and go, well, why don't we run that with the stealth modifier? Well, that modifier is a bit of a misnomer. Don't be tricked by it. All that the stealth modifier does is instead of collecting from every machine in the network, it only collects from file servers and terminal servers and domain controllers. The problem is that in order to determine whether a host is a valid collection target, it still has to reach out and authenticate to that host and check with it. So it's not really stealthy at all. I usually refer to this modifier as skid bait. Now let's get into the fun stuff. DC only. I actually don't, I'm curious, from the people in the room who do Bloodhound, How many of you use this data collection? Does anybody use Bloodhound in this room before? Do you use DC only? Okay, no worries. So this is as sneaky as Bloodhound or as Sharphound gets. So the cool thing about this collection is that you get group membership, all the ACLs, all the OUs, you get object properties, you get local group information as well as local admin information, as long as those admins are deployed via GPO, but in most enterprises, that's how admins are generally made. Excuse me. So, but the cool thing about this is you can grab all this data. This makes up about 85% of the Bloodhound collection, and you can do it with only talking to one domain controller. So the odds of this getting caught, I have never been caught doing a DC only collection. I've been caught on execution by Sharphound because it wasn't obfuscated well enough for the EDR, and I've been caught doing the other half of this collection, which is the other half of the all collection, which is just because I was doing one-to-many relationships. But this almost always gets by. And the reality is outside of session data, which is very valuable, but that is the only kind of super valuable data that you don't get from this collection. And so I can already start planning my attack paths out throughout the domain before I ever really start tipping my hand that I'm doing something. What's up?
Good question. And again, I'm extremely ignorant on Bloodhound.
Okay.
So,
That's why we're doing a 101 class.
So do you not have to specify a target? I mean, it mentions
Nope.
this is one domain.
So what happens is you can specify, there's flags to specify a specific domain, but what it does is it uses the credentials of the session you're in, and it just queries whatever domain that user is joined to. So if you're not in an authenticated session, you can pass a username, password, and domain flag in order to authenticate to a different domain. But for the most part, you just, like I said, this is exactly what I end up running, plus a few more flags that I'm going to show you. Bloodhound's, the Sharphound's actually pretty intelligently written. Like, it's great because a lot of times I'll land on a host. Like, say I fish my way into a network. I'll land on a host. I have no idea the user's credentials, but I am authenticated to the domain. So I don't have to have those credentials in order to do a Bloodhound collection and start moving elsewhere in the network where it's better located for me. It was a great question. I want to talk a little bit about some other OPSEC considerations for Sharphound. When stealth is a factor, I said this a couple times before, I'll say it again, always, always, always start with DC only. So the cool thing about how Bloodhound's data is set up and ingested into the database, if you add more data, it will just add it to the existing database if you don't clear it. So you start with a DC only collection, and then later on when you're a little further along in your operation, and usually for me, I still want that session data. That is super valuable. When I have a host that I can afford to burn, I don't mind getting caught on, I will set it up. I will make sure that there's no connections to my current operating C2, have a dirty C2 set up on it, and then I will run, there's another collection method, I didn't do a slide on it, but it's called computer only. And basically DC only plus computer only equals all. So I get that last 15% of the data, and then I just toss it into Bloodhound, and it'll add everything together for me. So then I end up with a complete picture, and I don't have to expose myself for it. I know a lot of red teamers. I'm not necessarily in the majority when I say that I run Bloodhound on every single op, every single Windows op. But I think the data is valuable enough that it's worth taking the risk of getting caught on a host as long as I understand where that risk is and I've prepared myself for it.
If you know what you're doing with Bloodhound and you know how Bloodhound works, what risk is there?
Well, as soon as you run computer only or any collection that involves reaching out to every machine in the domain, I know every network that I've personally touched has a one-to-many SIM search for SMB because it's just so easy to catch Bloodhound usage. Because if you want that data, that session data, you have to make that type of a risk. So that, yes, there's a risk, but I mean, I get where you're coming from. I don't consider it a risk because I know that, hey, when I do this, this is going to get caught most likely. But I've already prepared for that. I'm on a dirty C2. I'm not connected back to my primary op. And I make sure to take the steps to separate myself beforehand so that even when that SOC analyst goes, oh crap, Bloodhound, someone's running Bloodhound in our environment, let's go re-image that machine, or God forbid they actually start an investigation, I don't end up getting my whole op burned. They just burn the thing I intended for them to burn. Sometimes setting things on fire is okay. So yeah, this was all Trey's good mind for that. I was like, I couldn't come up with a good name for this because otherwise you were going to be Intro to Bloodhound Analysis. So going back into some of the tricks I use to get Bloodhound by and minimize my risks. The first thing you need to be aware of is, by default, if you don't specify this memcache flag, Bloodhound will drop a cache file to disk in whatever your current working directory is. That cache file is signatured all to hell and will light up every single AV and EDR you go in, including Garbo Defender. So use memcache. It actually really is, but use memcache. This flag, I honestly still don't understand why this isn't the default behavior in Bloodhound because I don't know a single red teamer who runs Bloodhound. This used to have a different flag that was called no save cache, and it just dumped the cache file entirely and just didn't do it. I like that better because that cache file is kind of worthless to me. But the memcache is cool because now it's just storing it in memory. But I suspect, given another, I don't know, 6 to 12 months, and your EDR vendors are going to start finding this cache in memory and screwing it with us again, and they're going to have to go back to giving us a no save cache option. The next one I want to talk about is, by the nature of how Bloodhound or Sharphound works, we're running Sharphound independently of where we're going to run Bloodhound. So it drops a file. It has to package all that information into a zip file that you're going to exfiltrate. That zip file has a very predictable naming convention. It is literally timestamp Bloodhound. And then I think the last 4 letters are random characters. So you can randomize that file name using the randomized file names flag. There's another one that I didn't have up here. I didn't really want to do 2 that were for the same thing. This is what I use, but there's another one if you want to be a little more deliberate in how you in your file names. You can actually specify exactly what the file name is. Bloodhound doesn't care about extensions or anything like that when you import the data. So for the longest time, I used to name things like bank enrolled XLS. What's up?
If I wanted to take outputted data from Bloodhound or Sharphound output and roll it into something like Red Elk, for instance, how would you
roll it into
Red Elk?
Red Elk?
Yeah, how would you that data?
Doesn't Red Elk have a Bloodhound parser?
Yeah.
So yeah, you would just import it into Red Elk directly with the parser. It's JSON.
What addition, aside from the default outputs, because you can configure logging outputs with meaningful data from Bloodhound, which you know, what other data would you add that's meaningful on assessment that would help you with reporting?
Any type of host information that you can pull, like at that point, you're just plugging in holes. You get 80 plus 90% of the data you would need is already stored in AD anyway, and it's collected by Bloodhound. So you should just be able to parse that file and then just add contextual information. That's off the top of my head. I actually don't use Red Elk. So I've seen it, I've demoed it, I just didn't see a ton of value for me. My team, all of our operators, we don't generally run multi-operator operations. So I don't, generally it's one operator per op. So there's not a lot of use for us to use Red Elk in my team at least. So make sure you run you either run the set file names, -- set file name, or -- random file names. And then the last thing is, it's a zip file. Inside that zip is a JSON, and that JSON has Bloodhound and all other things written all through inside the file. So encrypt your zip, otherwise you're going to get owned. And then the last one I want to talk about is those pesky network and IPS signatures, those one-to-many relationships. Another one of the ways I see, the one-to-many is still really solid. It's probably the most solid detection I've seen for this. But, and this does not bypass that. But the other one that I see a lot of is looking for an abnormal amount of LDAP requests from a single host in a certain period of time. You can get by that by setting a throttle. The throttle is a millisecond value. The ends are the numbers. But you do throttle however many milliseconds. That's every LDAP request it'll make, it'll pause between it. The jitter is another one. When you insert a throttle normally, it starts looking suspiciously like malware beaconing. So you do want to add a jitter whenever you use throttle. And actually, I tell all of my junior operators that when they're running, I don't care whether you're worried about it, put in a throttle of like 100 milliseconds just so you can jitter up the data, because otherwise those LDAP requests start looking really suspicious just because of the rate they come in at. So set a throttle, set a jitter. Little side note, there's a lot of different tools that allow you to set jitter for when they respond. Anytime you're doing that, use an odd number for your jitter, because they can get stuck in sequential loops when you use even numbers. So always use an odd number for your jitter.
So, real quick question on the jitter. With Bloodhound's execution, is it like the number you put is going to be the percent jitter left or right? Or can it do like Beacon does, where if I say I want my jitter to be 20 seconds plus or minus, it'll actually take anywhere within 20 seconds left or right. So it might be 5 this time and 18 next time.
So jitter and Beacon is still percentage. It's a percentage of your sleep.
Yeah, that's what I mean.
And it works the exact same way. You are saying plus or minus this percentage.
Yeah.
So it could go down, like if you say 50% jitter on a 1 second, it could go as low as half a second or as high as 1.5 seconds. Yeah. So it does spread it across both sides of the spectrum.
So this does the same?
Yes. That's actually that was a really solid question. Thank you. All right, so just to kind of tying it all together, of like this is generally how I run SharpHound on ops. Is what you're seeing here. It's the DC only followed by memcache. Basically everything we just talked about. That is my standard Bloodhound command or SharpHound command. I will add a few others. Go ahead.
Can I throw you a softball real quick?
Yeah.
For an aspiring red teamer, what about Windows internals that they need to know about to make them as knowledgeable about SharpHound and how it works as you are?
For Windows internals, like actually picking apart SharpHound the program, or picking apart like how the Active Directory works?
Yes.
Yes. Okay. You need to. Yeah, I say you need to understand basically Windows API calls that deal with Active Directory, Windows API calls that deal with execution. That'll help you pick. Basically, if you can understand both those sets of API calls, you could take SharpHound apart and rebuild it if you wanted. As a matter of fact, I recommend doing that because if you have your own version of Sharphound that it outputs the exact same data in the exact same way, but uses its own unique code, you're never going to get caught. It's unique.
How many here didn't know Windows had an API? Be honest. All of you. You're all liars.
As I say, so this is a good time any since you tossed that one to me. If you want to learn more about Windows APIs, come talk to me here after the holidays because I am actually doing a malware development order inside the temple. So you want to learn more about that? Come talk.
Please teach me how to bypass Windows DP API, please. It's killing me right now.
DP API? What do you mean?
DP API is murdering me right now.
Defender ATP?
No.
DPAPI is we don't want to bypass it. We want the DP API. DP API gives me free creds.
Yes, and well-configured DP API right now is murdering me. Talk after.
Oh, we'll talk after.
Yeah.
Because I'm not sure I'm following what you're saying. Because yes. All right. So yeah, that's kind of wraps up our talk on our section on Sharphound. One last thing, and I just realized that in my edits of my slides, I dropped a slide somewhere. So the last thing I probably should say, I just told you how to collect the data and get those zip files, but I didn't tell you how to get it into Bloodhound. It's actually pretty easy, so it's not a big deal. When you open up the Bloodhound app, you literally just drag the zip file onto the window, and it'll ingest it. But yeah, I had a slide about that apparently that I lost. Yeah, no, I think it was. I know when it got cut, but so okay. So actually, first let's talk quickly about graph theory, because the rest of this is not going to make a lot of sense unless you understand at least some basic terms. So in graph theory, we have two major types of objects. We have nodes, and we have edges. So what graph theory attempts to do is it performs calculations by looking at the relationships between one node and another. So the nodes are your actual objects. So in AD, a node would be any Active Directory object. So your computers, your users, groups, all GPOs, those are all nodes. And then edges represent types of relationships between nodes. And that's where graph databases differ from a traditional relational database. Is a traditional relational database, there is one relationship between each set of objects. Ish. So this allows us to have, because we have these edges, we can define multiple relationship types and still perform calculations using different relationships on either side. Not to go too in the weeds there, the best way I usually describe this is I like to talk about Google Maps, because Neo4j was originally what Google Maps was run on. So what happens is when you ask for directions to Publix on Google Maps, it looks at in their database they have every address that they know about. And then and those are all the nodes. And then they have all the edges those are streets, sidewalks, trains. All these are different edge types. So then what they do is they sit there and they say, okay, you want to get from node A to node B. So it looks at node A and it looks at all the edges. So it sees you have Elm, Poplar, and Pine Street coming that you can come off from point A. And then so it will keep branching that out from both sides until they start seeing those connect. And when they start seeing those connect, then it'll eliminate everything that didn't connect, reduce all those to the shortest paths, and then spit you out whichever one's the most efficient. That is graph theory in a nutshell, really, is you go point A, I can get to point A to point B to point C to point D, and eventually end up where I want at point Z. You had a question?
Yeah, would this be like ports that connect the nodes?
So the edges, the edges are relationship types. Like the type of relationships we see in AD would be, or specifically in Bloodhound, they're not AD specific. So like edges we use really commonly. Admin to is an edge. So this user is an admin to this computer, that's an edge or a path we can take.
Memberships and permissions.
Yeah, so I'd say all of your like Active Directory permissions are also edges. So yeah. So the same thing with Bloodhound. When Bloodhound is all about pathfinding. It's I am here and I want to be over here. How do I get there? Usually there was before Bloodhound there was a lot of like I got these credentials. I don't know where they're good, but I'm going to try logging into everything with them and see what happens. Oh, I got over on this machine. Let's hope there's some new credentials I can find or something like that over here. That's old school like AD exploitation. I mean, it's not quite that bad, but it really boiled down to a lot of just getting lucky. Now with this, I can actually ask. I can go into Bloodhound. I can say, I am this user. I just fished onto this host. I have access to this user and this host. I want to get to domain admins. Show me a path. And Bloodhound will calculate it if it exists. So yeah, that's kind of the idea, the high-level idea of graph theory. And I do always like to put this up when I'm talking Bloodhound. I've had this in my last talk too, but John Lambert made a very famous quote a while back saying, defenders think in lists and attackers think in graphs. And as long as this is true, attackers win. I think this is as true today as it was then, other than the fact that I think defenders are starting to think more graph-like. That anytime you hear people talking about like defense in depth strategies, that is a defensive graph of detections. So traditionally, we would have block lists. We would say these IPs are bad, these IPs are good, and squeezing between those is very easy because all I got to do is find an IP that's not on your list. So and as attackers, when we think in graphs here, I don't really care which piece of tradecraft I use to get to domain admins. I care about being a domain admin, or I care about stealing the information that I would be able to get, or deploying ransomware, or whatever my motivation for being on the network is. So because you have these 1 second, I saw you. Because you have these things going on, that we just kind of learned to like slide in between all the little cracks and holes that are left in the defense, and Bloodhound helps us map those because we can see those defenses. We can see that you have good you have good ACLs and things like that, and so but we can go around in a different way. You had a question.
Yeah. So is this because defenders are always taking like a risk acceptance mindset, and lists are easiest to like scale up and down in the org?
That's a can of worms. I don't know that I want to get super into right now, but the question, yeah, thank you. The question is asked if the reason, and I'm sorry I haven't been repeating the other questions, that if the reason that defenders tend to think in lists is more about like being in a more risk acceptance mindset, or worrying about scaling up and down with your org. I think the main reason that defenders, for the most part, think in lists is for the longest time that's just how it was done.
That's how IT work is done. SOPs.
Yep.
Don't do the checklist.
Yep, exactly. That thinking laterally and dynamically is generally not like the classic engineering mindset. Probably, I'd say most of the modern engineers that have that type of brain are in our field. It attracts them, and we make good money. So we snatch them all up. Defenders, what I'm seeing now, and actually a lot of the best defenders I see now, they're people who have been on my side of the house. They're people who come from the offensive world. The same thing with good attacking. You need to learn both. You need to understand, because as an attacker, you can't evade what you don't understand. And as a defender, you can't defend against when you don't know the tradecraft that's going to be attacking with you. You can't even write a good list if you don't know what the list is for. All right, so we're going to get a little bit more into actual like analysis and like kind of like using the Bloodhound UI. So the first part I want to show you, this is the node info panel. This is the panel you will see This one and the analytics panel are probably the two ones that you'll spend most of your time in. This pops up anytime you select a node in the Active Directory from your Bloodhound data. And the first part I'm showing here, this is the this screenshot here. This is what we call the summary area. This part is there's two really cool parts in here because we use this as a pivot point. With this, like generally, this is something we're thinking about targeting or something we've already compromised. But what we really want to know is we want to know what users are logged into the host or what host the user we have can log into, and that's what the sessions shows us. If you're on a user account, it'll show you which host it's allowed to log into, and if you're on a actual host object, it'll show you what users are logged into that host. And all of these little numbers here that you see in this screenshot, these are all clickable. And when you click them, it will actually pivot into a graph showing you those users and showing where they can go, and you can start branching out as deep as you want. That's pretty useful, but the one I really want to bring up is the next one in the list. It's the reachable high-value targets. So one of the problems that I run into commonly is the size organizations I go after are like, they're large multinational, energy, healthcare, things like that. They're hundreds of thousands of users in computers. So when I run an analysis, which we'll show here a bit, when I actually run an analytic query, the number of results I might get are hundreds, thousands even. And they're enough that Bloodhound actually warns me when I run the analysis that, hey, this is going to take a really long time to run and draw. Are you sure you want to do that? And I usually tell it, no, I don't. Just give it to me in a spreadsheet, and then I can go check that. But this allows me to really quickly, this reachable high-value targets allows me to really quickly triage a object that I'm looking at. So by default, this slide is an older slide. This is a little out of date. There's actually like, I think 16 default high-value target groups. I wrote this slide originally in Bloodhound 2.0 when there was 2. But there are default groups. You can go to Bloodhound, read the docs. There's a whole article on high-value targets. These are by default, but they're your big, highly privileged groups. Obviously, domain admins is usually where we want to get, depending on what we're trying to accomplish. But what's cool is whenever you look at an item, the first thing you see, well, the second thing you see after sessions is reachable high-value targets. So if there is a path from this object to one of the high-value target groups, it will highlight it there. And then if I click that, it'll show me step-by-step how to get there, which I'll show on the slide in a second. The only other thing I want to note is this is also configurable. So if you are on your network and you come across Citrix admins, or a group called that, or something like that's very obviously highly privileged and valuable, all you got to do is right-click that group object, and there's a drop-down that says Edit to High Value, so you can edit your high-value groups as you go. And I highly recommend doing that, especially if you're on a complex op, because what will happen is you'll start chasing a path, and inevitably, somewhere between point A and point Z, you're going to end up running into a brick wall. You get detected somewhere. You find that it's got CrowdStrike installed or something, and you end up having to go rethink. But you're going to learn things along there about the network as you're exploring. And so as long as you keep your Bloodhound up to date with your high-value groups, the same thing like with user objects and computer objects, you can right-click them. If you've compromised it, right-click that object in Bloodhound, mark it as owned. It means you've compromised it, and Bloodhound will save that. And then you can actually run an analysis that says, called shortest paths from owned principles, that says, I want to get to this group. Show me the shortest path from anything I've already compromised. And if you keep that up, Bloodhound will make your job a lot easier. So I want to show you kind of the graph. So this graph is it's a very simple example, a very contrived example. But So over here, we have this PCI server, and you can see the little blue dot there. That means that's the starting point of the graph. I clicked reachable high-value targets from this one, like on this last guy here. I would have clicked that number 10. Ignore that the numbers don't match up because I was trying to make an example. But the first thing I see is so we talked about nodes and edges. So all the circles, these are nodes. All the edges are your lines between them. So right off the bat, I see I have a has session edge for the domain administrator. Well, that's convenient. So what this tells me right off the bat is that the domain admin is logged into this box. So if I have privileged access on this host, if I'm an administrator, I can steal that user token and, whoops, I think, hang on a second. Chris, am I still sharing?
No. Just went off.
Yeah, I wondered if let's try again. Sorry about that. I'm having some Wi-Fi issues here. Am I back on?
Not yet. Oh, there we go.
We good? So if I've got privileged access, I can impersonate that user. If you have admin rights on a host, any user that's logged in, you can steal their authentication token and pretend to be them on the network. So that's already DA. But kind of to stretch this about more for the example that I'm trying to give here, like if my goal was to compromise a domain controller, because why not? I mean, if I get on there, I can dump every NTLM match in the domain. I have a path here. So my first step would be to steal this user authentication token that's logged in, and then I can use that authentication token to log into the DC. This is a very simple path. Most of the paths I see on real-world ops are usually 10 or 12 steps. But the cool thing is, come on, get focused back. All right, there we go. So the cool thing is Bloodhounds. You normally won't ever see me tell you to go look at the help file for an application. But Bloodhound's help is actually really cool because if you right-click any edge in Bloodhound, if you're like, okay, Bloodhound says this is interesting, but I don't have any clue. For the longest time, I used to see these paths that involved write DACL. I had no idea what that meant or how to exploit it. But if you open up the help, and it'll start on the info, which isn't super interesting, but you click on this abuse info tab, and it'll show you step by step how to exploit this path, right down to having the PowerShell that you need. This is awesome for like when you're just kind of learning how to get through Active Directory because, and then the other cool thing, this offset consideration. This will tell you like what you need to be worried about, like where you're likely gonna get caught. Yeah. I cannot keep a steady. Neon Temple just keeps dying on me. Here.
Why don't we try?
Yeah, one of the other ones.
Try blackface.
Yeah, that's the sketchy looking one.
Which one?
Blackface.
It's the.
You don't have anything on there
Okay.
that you don't want to share, do you?
If you hack this PC, you'll get nothing because I think I've opened this laptop more this year talking to you guys than I have in the last 2 years.
Those are O's, not zeros.
Show password.
I'm gonna bring this useless laptop here.
Let's see if that works. Thank you.
Can we get some hard lines in the new space? Did it connect?
Oh, no, let me try. Oh, I see what I did wrong. Hang on, my finger slipped off the shift key.
Okay.
User.
Yep, PEBCAC. Problem exists between user and keyboard.
I haven't heard that one yet.
Why are you not connecting? Can you bring that back for 1 second? I just see if I thought I had it right, but I don't think I do.
Everyone talk amongst yourselves.
Unless those are actually O's.
I guess they.
Yeah, let's try with O's. Oh, hang on, I missed. This helps if I actually type the whole thing. That works. Looking good. Last time it just immediately popped back on me.
Oh, okay.
Oh, nope.
Yeah, unless those are zeros, I don't know.
Yeah, right now I'm doing it with the zeros. Let me try them with.
Oh.
Let me try capital O's.
Yeah, I think they're capital O's actually. If this doesn't. Okay. What we can do is I can turn the camera and do the screen.
Point at the
here.
screen?
Yeah.
Okay. Yeah, I can do that. Yeah, and I can just move a little away from the.
Chris is a solution man.
Sometimes going low tech's the right way. All right. Sorry for the technical difficulties there. Let me know once you're focused in, and I'll continue. All right. So, yeah, like I was saying a minute ago, like the help section, help is actually really good in here for this. The last thing I'll mention on the help is the references thing. Like almost every one of those. This is a SpecterOps tool, so there'll probably usually be SpecterOps blogs. So if you're not a fan of them, you may want to look elsewhere for your references. But there's usually, do what? No, I don't know what you're talking about. I never worked for those guys ever. But yeah, the references will give you like detailed write-ups like of like how the exploits work, all that kind of stuff. Don't shy away from the help, especially like the one I have an example here. This is a generic all. Actually, for the longest time, I had no idea what write DACL, write DACL, what that permission meant, and it came up in a lot of my shortest paths. And then when they added this in, like that was where I learned my first time of like actually successfully exploiting resource-based constrained delegation, which is an abuse that one of the 3 pieces of tradecraft that I know we're going through on the next section in Q1. So it takes about 15 or 16 commands to successfully do, so it's not easy. And that leads me to, of course, my obligatory cat meme for any talk. I mean, you can't do a hacker talk without a cat pic, right? I can't. So the next thing we're going to talk about is Bloodhound analytics. So I'm going to use a very simple piece of tradecraft to explain this because I find real-world examples to be a lot easier and a lot more interesting than just going through a little more just theoretical talk. So if you were at my last talk, you would have had to sit through my 15 to 20 minute discussion of how Kerberos works and try to pretend you weren't asleep.
You say that like it's a bad thing.
I mean, it's dry content, but it's so important.
Your crowd is here.
But I'm not going to go deep in the weeds here. I'm going to give a quick kind of tactical explanation of what Kerberosing is. So anytime there's a service account in the environment, and the service account means the account has a service principal name attached to an Active Directory, you can request with no privileges, just regular domain user privilege. You can ask for the Kerberos to give you a ticket to log into that with that user, and you can then reverse that ticket to find out the password for that user. What? I'd say Kerberosing. This is an old technique. It's been around for ages, but well, it will never get fixed. Microsoft, yeah.
It's working as intended.
Yeah, it is. Yeah.
Feature.
Feature, not a bug. That's
So
exactly what they say.
But yeah, but basically, the reason I bring this up is, even though this is, God, 11, 12-year-old Tradecraft-ish, I mean, I'm not kidding. About a third of my my domain compromises, at some point or another, I will Kerberos. And because getting plain text credentials for a service account is awesome, because service accounts are usually very privileged. They're at least privileged somewhere, if they're not privileged everywhere. The other thing to remember, and so like kind of like where I'm going to show you here. So tooling makes this really easy. I like to use Rubius. You know, as Badger pointed out, I am a former Spectre op guy, so I use a lot of Ghost Pack. But Rubius. Do what?
Don't worry, they'll tell you.
Do what? Oh yeah.
Don't worry, they'll tell you.
Yeah, except it's a mix of pride and shame for me. No, I'm just kidding. No, it's but yeah. Bottom line is, you run the Rubius tool, you type in Kerberos, and it will spit out every Kerberostable hash in the domain. This is the traditional way we used to Kerberos all the time. We just go get it all. But the thing to remember here is, every action we take is a chance for us to get caught. And when you're doing this, even though you're running one command, you're taking a whole lot of actions. You're asking for hundreds of tickets. Because how it actually works underneath the cover is, it makes a TGS request for every account. And the KDC will go, I'm sorry, that's not a service account, and it will just drop the request, but it doesn't care. It will send the responses for the ones that are valid. That's actually pretty abnormal, and if you're actually looking at the Kerberos logs, it's very obvious what's going on. So how can we do this better? So this is a great time to talk about the analytics. Or I guess this is, my screenshot's a version old. And now it's called the analytics tab instead of the analysis tab. So inside of Bloodhound, yeah, we can do all the manual analysis, like I was talking about, using your paths or shortest paths, or not shortest paths, your reachable high value targets. There's a thing in there for every user object. It'll tell you where it has administrator to. There's all those little things in the node tab, and that's great. That's actually how I do most of my analysis. But there are some things that automating it's just a little easier. And that's where the analysis tab goes. These are pre-built Cypher queries inside. So in this case, like, we have one that'll show us all Kerberostable accounts in the domain. So why do we care about this? Well, the test one, or the test data I'm running with, when I dumped that, this actually returned 114 results. And that's actually kind of small for what I see if I run this in most orgs that I run in the real world. I usually will find an average of, like, for every 100 users, I'd see 1 to 2 service accounts. Like, it just comes up. They're very common. But but again, earlier we were talking about using Bloodhound to quickly triage. What I noticed is, as I was just clicking through some of these, like right off the bat, I can see that 9 there for reachable high value targets. So I know that there's a path there. So I go look at that, and I see, okay, now before I was going to go blind Kerberos. I was just going to dump everything and see what I got. I didn't know whether the juice was worth the squeeze. I didn't even know if there was anything that was really going to be useful to me. Now I know there's at least one useful account in that data. More importantly, I know which account it is, which means I can tell Rubius, I just want that account's hash. Now, if anybody here is used to looking at Kerberos logs, or has in the past, finding a single TGS request in the Kerberos logs that tend to roll about every 2 hours on the DC because there's probably about 1,000 of those going on a second in a large organization. Finding that my one rogue request is almost impossible. Unless you're doing some other types of analysis. You're not going to get it from just the Kerberos logs.
Honeypot accounts.
Honeypot accounts, yeah. Other ones is look at the data from all the endpoints and look for a Kerberos request that's not coming from LSAS. But yeah. Anyhow, they're everything's sneaky until someone's looking for it. People aren't usually looking for this, like not that one TGS request. Most of the analytics I see looking for Kerberos are looking for an abnormal number of TGS requests. And so this would not flag that. So all in all, when I actually triaged all these, there were about 20 accounts. So originally I had a little over 100. So I went from so I would have gone from 100 users a chance to get caught down to 20. That's not a bad reduction of risk. But we can actually use a different one here, the different analytic that will actually automate even that for us. Rather than having to go analyze and click through all those, I can just run shortest paths to domain admins from Kerberoastable users, and it does what it says on the tin. It's going to show me this cool graph, and all of the green dots on the left-hand side are the users that are Kerberoastable, and all of these edges are the paths it takes to get to domain admins. It's really this right here. Like not only now do I know what the actual whether there's something worth grabbing on here, I also know that like roughly how difficult that it is going to be to obtain that, but based on the number of hops that are involved in the attack chain. So things like like this one, like right here, this Terra, like there's only 2 steps I have to take to domain admin. But going out here, some of these get much longer. Now, those 2 steps might be more difficult than those other ones. Like I come across chains where I got a Kerberoastable user that is an admin to one host, and that starts a chain of just jump to the host, steal a set of credentials from that host, jump to the next host, and I might make 9 steps, but it's still a lot easier than necessarily doing like resource-based constrained delegation or ACL abuse. So there's still some analysis involved in looking at that, but that's what our help menu is for. Go ahead.
How often have you used this graphic in reporting?
This graphic?
Yeah.
All the time.
Okay.
Well, actually, no. Let me rephrase that. No, not this specific one. Not Kerberoastable. I do shortest paths graphics all the time because a lot of times I'll take a red team and I'll accomplish the objective, and but then when I'm in my reporting, since I've already done all the analysis, like I will put those reports in along with the Bloodhound data for them to look at, because I might have taken one path then there might be 100 other versions of that path all on the same thing. So a lot of times I'll do a graph that looks a lot like this, but it's the shortest paths to domain admins. That graph I do put up in almost every report. But that's a really valid point. Like from a work perspective, these type of visual graphs will say more to a client than 10 pages of narrative work. And you know the
pictures of his wife and kids that he stole from his desktop too.
I think I'm real defensive.
Yeah.
That's not your wife.
Remind me to tell you about at some point about the CISO I fished.
Oh, fucking
That was the only time I got called a fucking asshole in the middle of an executive readout.
Yeah. So there was one that I did back when I was an intern, where we got the CFO of the company and we got the affair he was having on the company.
Ooh.
Yeah. That was fun.
Hell yeah. Fuck him up.
So like taking what we were showing here, we have about, like I said, we have around 20 accounts so that honestly, so because Kerberoasting, you get a hash, but that's not you can't use that hash for authentication. You still have to crack it. So I would probably dump all 20 of these accounts because I would want to because the odds of cracking one hash are a lot lower than cracking 20. And the amount of time it would increase my cracking time would not be enough it would be negligible.
All your 3080s?
Hey, I've got 4090s in that host now.
Sorry.
my two 4090s have more cracking capacity than the 73070 rig that was in my that's in my office. I leave that for the junior guys because those peasants. No. God, you know what? I just realized that I actually invited one of those guys to this talk, and he's probably on the stream. Oh, tomorrow's morning meeting's going to be awkward.
Oh, quick order.
But yeah. So as I kind of mentioned earlier, originally we had 100 chances to get caught. We end up dropping that down to 20 and reducing our exposure by about 80%. And all in all, like, had I skipped the manual stuff and just went straight to the shortest bet, that would take me about 5 seconds to run. So 5 seconds, a lot less exposure. That's kind of the power of the Bloodhound analytics. There's not a single bad analytic in Bloodhound. All of them are really cool. They will find just about anything you can need for a normal op. It's a Swiss Army knife of finding tradecraft and paths to get to places. Which brings me to kind of the last topic I'm going to talk about tonight, and that's the cipher query language. So we talked about analytics that are built into Bloodhound. If there is not an analytic looking for what you're trying to do, if you got this weird edge case, you can write one. Cipher is a pain in the ass, just full disclosure. And I'm not going to go super deep in on this because I am not a cipher wizard. I will show you guys the basics because that does everything I need it to do. Generally, when I'm writing a cipher query, it's because I have this really weird edge case that is going against a large data set, and I don't want to manually analyze all of the nodes. So, couple of things about it. So, just like any database application, it's got a query language. Did you have a question? Oh, okay. Sorry. No worries. So everything we do in the Bloodhound application is just a GUI way of running a cipher query. And what's really nice about how Bloodhound is designed is at the bottom of your Bloodhound panel, you have this raw query button. I have it expanded right now. This is normally not expanded. But if you click this, anything that you run in Bloodhound, it will show you the exact query to run that. You can also paste in your own queries into here. I don't recommend doing that because Bloodhound is, if the query fails, which at least if you're me, who's not very good at cipher, the first time I try to run a cipher query, it will fail every time. And Bloodhound doesn't give you any feedback on it. It just doesn't present anything. If you're, and I'll talk about this on the next slide, I guess I can go ahead. If you're actually going to be to be writing your own queries, I recommend going back to that localhost or home 7474, that web panel for Neo4j, and run it inside the Neo4j console because it is a proper like DBA style console. You can write multi-line queries. It'll tell you exactly where the query is erring when it errors. It'll make your life so much easier. So this query I have kind of in yellow here. We're going to talk to this kind of line by line. This is a exceedingly simple query. And even to me, even this really easy query looks like a mess to me, especially when you don't have like half of the fourth line snipped out because you've got 100 edges in that list of edges. But so kind of DB 101 for in a database query, you need two parts. You need a match statement and you need a return statement. So you can have multiple match statements, but you can only have one return. So this one is a simple one. So I'm going to actually work backwards a little bit on this because I find it a little easier to understand. So I'm going to jump around a bit. So in this case, when I wrote this one out, I just started. I knew I didn't have anything fancy I wanted to do with the output, so I just did a return variable. So that's return p. And then I started writing my actual query. So what this query is doing is looking for a path from Greta Pickett to domain admins. So so think about what data I need. I need to know the properties and edges for Greta Pickett. I need to know the property and edges for domain admins, so I can start that path going back and forth to connect. So the first thing I did is I'm just doing a match statement in line 1. I'm searching by user SID because searching by usernames in AD can sometimes get some funky results. AD doesn't really care if users have the same name, so it does. So you can end up with something. I just wanted a positive ID, so I used a SID. I know that's going to be unique, and I did the same. And so the first thing I did is my match command. I'm assigning this to a variable. So in is my variable. I just put a label on it. It makes it easier for me to read. You can drop this :user and it doesn't matter. This just makes it easier for me to read the query. And then I'm going to look for the object SID, which is and then that's the SID of the user. And I'm saving, so because I started here, and this is all in braces, this section here, that's how you define a variable in Neo4j. It's the variable name followed by curly brace, your function to get the data, and then close curly brace. And all that match statement, all the match statements start with open and close parentheses, so I just have to get all my syntax right. I'm going to do the same thing I did there for the domain admin group. All the action's going to happen here on line 3. So I am defining a variable. I didn't label this one because it's just being used to return. You can, so if you're doing a variable that is not inside a match, like an overall match statement, you define it with an equal sign. For some reason, if it's inside parentheses, it just doesn't work. So cipher being cipher. So I generally will just do labeled variables, because if I'm labeling the variable, it will always be variable label space and then the path. So the next thing we're going to do is we're going to run a function. So this is a built-in Bloodhound function. Actually, this might actually be a built-in Neo4j function, if I remember correctly. But this basically, what this is it's telling what type of calculation to run. All shortest paths is the one I was talking, like the Google Maps example. Start from each end, spider out until they connect, get rid of all the noise, and then show me the shortest ones. So I'm going to do all shortest paths. I'm going to call the variable. And so my variable n, this is my user variable. So this is one end. Note that I've got it in parentheses. So when you're calling a variable, you have to tell Neo4j what data from the variable is used in this calculation, since there can be multiple types. So in this case, parentheses are wrapped around a variable name tells Neo4j that I want the node data out of that variable. Because when you match all this before, it's going to grab all the data, not just the node data. It'll grab the node and all the edges connected to it. I want to isolate just the nodes, so that's why I have it in parentheses. And now, I know this is for people who are used to doing coding or DBA work, this is going to be a little weird, but I'm going to skip to the end of this line now. Note, and then here on the other end, I'm doing the other side of the path. So this is the group, and it's also in parentheses because I'm wanting the node information from that. So there's the two ends of my path. Now, in between it, you see all like these dashes. So I hate this about Cypher. It's the worst thing. There's so many better ways to do this, but this is how Cypher does it. So that's an arrow. It's literally an arrow. You're showing the direction of calculation. So you do in, and then I start my arrow in between each part of the calculation. There will be a dash, and then if you want the order of operations to go towards the end, you put a greater than sign at the end, and to make it a long arrow. If you want it to go in reverse, you do the same thing with a less than sign at the beginning. And if you don't put your greater than or less than sign, it will run the calculation both directions. I figure I've never written a query that doesn't just go left to right. But so for the most part, I just remember that that each of my my nodes, and my relationship stuff in the middle, which I'm going to go over, I just put dash. I just write it out like that always. So now we're getting to the calculation sites, and so now we know that we're wanting to go from N to M. So what are we allowed, edges are we allowed to use? So the R stands for relationships. So we're saying the relationships we're allowing are only the ones in this list, and they're separated by the line. I can't remember what that actual pipe. Thank you. They're separated by pipes, so that is just database for or. So we're saying we want a relationship of member of, or admin to, or generic all, so on and so forth. That list had about 100 entries in it before I snipped it down for the slide. And so essentially what this line is saying is start it in, use any of the relationships I provided, and give me a path using those relationships to M, where N is user and M is group. And then I just return all that. That's, like I said, simple query. Still probably took me 5 tries to get that right in the Neo4j console, but that's because I suck at Cypher. I'm trying to double check my notes, make sure I didn't miss anything on here. Yeah, 4th line just returns the results. Another little random note, if you forget to do a return statement, Cypher won't throw an error, but it'll run the calculation and it'll return nothing and say it ran successfully. So don't forget to do a return. Technically, I could probably have put. I'm pretty sure that if I would have skipped this section here, I could have just done return and then that also works. Return with your calculation, but I kind of have all of my Cypher query. Like I just have a little blob that I start plugging in information for. It makes it easier for me to run it like this. It also makes it more readable. I'm going to pause for a second. Any questions on that simple query, or anything that I did not explain well enough? Because like Cypher is a pain.
Yeah, actually, the user and the group, are they both necessary because you're both using them in your query, and they're both part of the shortest path?
So I have this structured. So no, I could have done, instead of in, I could have done open parentheses, close parentheses, object SID, and define it that way. That would work. The reason I do it this way is I write queries that I'm going to save for later. And by doing it this way, I can very easily put that in. Sorry, excuse me, one sec. By writing it this way where I'm querying one and saving it, if I want to put it into the Bloodhound console as a saved query later, I have to, this is how it's kind of set up in order to fill in the data from the console. And I'll show you that in just a sec. Any other questions? Badger, do you want to?
What do you use to save these queries? Is it like Markdown? Like what program is it? Obsidian?
So what do you use to save these queries? Is it Markdown? Is it Obsidian, like Markdown for format? Is it Obsidian or what?
Well, I mean, I guess you could just introduce my next slide. So when you're writing these, after you've written these queries, and you find one that's actually useful that you might need to use again, there is in your app data folder or in your user data folder, like if you're on Linux, there is a Bloodhound folder, and inside there's customqueries.json. This is just a JSON blob. It's already got the queries that are built into Bloodhound. All you got to do is copy one of those blobs and paste your query in. But it'll all be done in JSON for Bloodhound, the actual application, to read it.
Do you have a particular program you use for your quote-unquote spell books or anything?
Like my editor?
Yeah, what do you keep notes in there?
Oh, God, no. No, I use VS Code. I'm not a like heathen. Nobody uses Notepad++ anymore. For everything. I take notes in VS Code. Yeah. But you know what I love is that I have 10 tabs open with 10 different types of code, and then a notes tab all in one nice spot on my machine.
And it understands it all.
Yes. It's code aware for all the types of codes that I write in.
So
So-
Trey said that you could understand that it understands
Couple of
it all.
notes with this guy, with this custom queries.json. Don't break the schema. Copy one of those, put them in, and then find the section that you see the cipher in and paste your cipher in. Because if you mess this up, then Bloodhound will just start crashing every time you open it. It used to run this after launch. Now it runs it as part of launch, so the program just hard crashes. Or if you're really lazy like me, you don't write cipher at all, and you just go to Halset's GitHub and steal all of his cipher queries. Because his stuff is really good. This guy wrote half the queries that are currently in the pre-built analytics, and he's constantly adding new ones. Other great place to grab this is like if you're writing cipher or you're just looking for easy ways to not have to write cipher, go hang out in the Bloodhound gang Slack. There's some really smart dudes writing cipher in there. And as long as you're not a complete asshole and generally like have made a little bit of effort like towards it, you post the query that and what you're trying to do, and there'll be somebody in that Slack who will help you finish it. So yeah, and I do have a link down at the bottom here to the custom queries from Halsec. I load this. This is just auto. Whenever I'm setting up a host to operate from, I load that JSON in for Bloodhound. They work really well. And now that I've taught you guys zero off for way longer than I intended, that's it for today. So, oh God, no.
Can you do any of this on Azure?
Crispy, take the microphone.
Yeah, no, don't give him the microphone. What? Badger, come on.
Bad, Danny. Bad.
No more cat memes for you.
Here comes fake Jeremy. Why am I being handed
Can
this? I don't
you
want
can you
this.
repeat the question with a straight face?
Hang on. Ask the question
So-
again.
Can you do any of this on Azure?
Yeah. So, are there any Hound related tools for GCP or AWS or Azure?
There are none for the other clouds, but yes, there is an entire Azure tool. It uses a different data collector. It's called Azure Hound.
Azure Hound, you say, and what does it do?
I'm going to throw something at somebody.
I have never heard of this Azure Hound.
So the Azure and Bloodhound has got a lot of great analytics and stuff built for Azure AD. However, it is not as robust in the number of analytics or the overall like explanation and help queries as traditional AD. All in all, it does work. Is the bottom line. I've used it. I just don't like Azure AD. I think Azure AD is a mess in general, and there's far easier ways to exploit it than to mess with Bloodhound.
How would you exploit it then?
Azure Fire.
So, the question was, what about a hybrid information? So, remember how earlier I was talking about how Bloodhound data is additive? Like you can just dump more data in and it'll add it all together. So what you would end up doing in a hybrid deployment is you would run the traditional Bloodhound or SharpHound to get data from the on-prem. Then you'd run Azure Hound. You throw it all in the same, and it'll build attack paths between them. It's real cool. I have taken over people's Azure deployments in hybrid sides and gotten just full control of their entire Azure cloud because they were dumb when they were setting it up.
People were dumb setting up their hybrid deployments?
No.
Never.
Did you have? Oh, I thought you were raising. Okay. Someone hand him the mic. Or make the poor guy walk and get it himself. Jeez.
My question for you is, what is your preferred way to extract those encrypted zip files from your collection?
Honestly, I wouldn't say I have a preferred way of exfiltrating those. It depends on a couple of things. One, what defenses I've already identified, what C2 platform I'm operating on, and how confident I feel. I mean, it's 99% of the time it is Cobalt Strike, and I have yet to have a detection go off when I use upload from Cobalt Strike, because it chunks it out in random chunks and rebuilds it back on the C2. It's running across the C2 line. It's dumping all the chunks into variables inside my profile. It makes it easy. But I actually have a really strong C2 profile for Cobalt Strike, a very custom. It's very difficult to find me on the wire. So that's why I like that. If I was using something like Sliver or something where I don't have as much control, I would probably use an HTTPS like file share, files SH or something like that, what I can do with a direct API call, because then I can do it straight from PowerShell. No worries. Any other questions? All right, then the last thing I want to say before I close out here, I mentioned at the beginning, there is a third part to this. The next part is going to be I'm going to be taking 4 different of what I would consider advanced AD attacks. We're going to talk about Active Directory certificate services. We're going to talk about resource-based constrained delegation. We're going to talk about, you know what? I'm going to leave the other 2 secret for now. Anyhow, I'm going to be doing live demos of how to exploit these and walking you through step by step from the discovery to the shell. So stay tuned for that. That'll be the closing of this series. Yeah. The last thing is come talk to me in Q1 if you're interested in the Maldev order. I'm still getting some of the content together for the early parts of it, and I know some of you have already talked to me about it. So I will be having more updates for that here probably in January. Cheers. Merry Christmas, everyone.
Thank you.